Okay, for our Algebra 1, Chapter 8, we got started in class by having you students write down what the definitions were of each. I just want you to add a few things on. The standard form, come underneath quadratic function and make a little bullet. Standard form of a quadratic, if you already wrote it, great, is y equals ax squared plus bx plus c. Now, I want you guys to remember that the parent, I'm going to put it out here, the parent quadratic that we've been talking about is the y equals x squared or 1x squared. Put that parent out here. And you should have a definition of quadratic function, a nonlinear function, and then the standard form. Put the parent out to the left, because that's what we've been comparing everything to. Now, in terms of parabola, the U shape of a quadratic function is a parabola. Maybe you just come out here and you just kind of go this way or this way, because it can be kind of like that upside down U. Maybe just draw that out in the margin next to your parabola definition. Now, it says the lowest point or the highest point is the vertex. The one thing I want you guys to say is the vertex will be written as an ordered pair. Vertex is written as an XY pair. And it's that highest or lowest. We actually, as time goes on, we might even talk about it as a minimum or a maximum of our parabola. I think that could make some sense too, the highest or lowest. And if you have a highest or lowest in here, where you see highest, maybe put maximum above it. Where you have lowest written, maybe go and put minimum above it, max min. Just because you'll hear me talking about it using that language. Add anything to your notes that isn't already there. It's a point, a single point. The axis of symmetry is going to be the vertical line. Do you guys have that in your definition? The vertical line that is like divides the parabola into mirror images, the vertical line. And I want you to just write down here that all vertical lines have an equation that's going to be an x equals something. And this is just going to be a number here. That x value comes from the x value of the vertex. X equals, it's an equation of a line. This is the equation. And what x is equal to, I'm going to actually move this arrow. What x is equal to is the x value of the vertex. So if my vertex is sitting at 0, 0, the line of symmetry for my parabola is going to be x equals 0. If my vertex is sitting at 10 and 2, my axis of symmetry equation is going to be x equals 10. My axis of if my vertex is sitting at negative 3, 5, my axis of symmetry equation is going to be x equals that negative 3. Okay, and we'll practice this together. As far as that goes, and this stuff was all off page 420 in your book. If you didn't write that on there, do so. That could help you too when you have to go back and look at things while you're working on problems. Also, you guys are logged into your textbook online, and when you get logged into your textbook online, it's easy to find places in your online textbook by knowing your page numbers. Now, I'm going to move down to the bottom part of this, the core concepts, and we're going to do some drawing and whatnot on it. If you have your markers handy, maybe grab them. There's our parent again. And remember, you guys, that parent, f of x using function notation, we could just put it in as y equals x squared as opposed to f of x equals x squared. The graphs of all other quadratic functions are transformations of the graph of the parent quadratic function, which means that that parent function, that parabola y equals x squared, where it sits, we're going to, just like we have been doing, we're going to talk about how an equation compares to it. Something gets skinnier, or something gets narrower, something gets wider, or something reflects over the x-axis. We're always going to refer back to that parent function y equals x squared. Now, some interesting stuff going on down here. When we talk about, I just want to go to the drawing first, and I'm actually looking at the picture on page 420. Do you guys notice how they talk about the decreasing? They show the decreasing and they use red on this side of the parabola. What they mean here in this decreasing area is x values are going down. As x approaches 0, as our x values approach 0, sure. As our x values approach 0, our y values are going down. When they say decreasing, they're just saying, as we move along the x-axis towards 0, that parabola is coming down. As we move along the x-axis towards 0, that parabola is coming down. Values are going down. And those values, if you remember, you guys, were the, what was it, negative, the x values. When we put in -6, it was positive 36. When we put in -5, it was positive 25. When we put in -4, it was positive 16. So when I had you in your groups, square those numbers. When you guys were in group 6, squared -6 over here on the x-axis, the y value was 36. When you squared -5 on the x-axis, we went down to 25. When we squared -4 on the x-axis, we went down to 16. When we squared -3, we went down to 9. Opposite side of this in blue, increasing. Increasing is going to mean that we're talking about as x values are above x is equal to 0. Increasing, oops, ing, means that as our x values move away from 0, in the positive direction, our y values are doing what? Our y values are going upwards. Our parabola could still keep continuing, but on that left-hand red side, the x values would be, or the y values would be getting smaller. The parabola could still keep increasing on both sides, but if we start riding that path down this way, as x is getting closer to the 0, their y values are getting smaller. When you're ready to move on, turn your page. Oh, no, I don't want to turn the page yet. Vertex. I'm going to grab my yellow marker and just highlight some stuff about the vertex. Vertex. The lowest point in the parabola that opens up, or the highest point on a parabola that opens down, is the vertex. You had that in your definition. I'm putting a box around it. Don't forget that a vertex is an ordered pair. And in the case of this, it's sitting at the origin. They don't always have a vertex at the origin. The parent's vertex is at the origin, but not all of them. And I'm just kind of highlighting that in yellow. Actually, I'm going to go take this yellow up top where vertex is too, and color code up top in my definitions. See what I mean? Just made that yellow. Every time I'm looking at a vertex, I'm using yellow.
Can you go back down?
Sure. I'm going to grab my orange for axis of symmetry. I kind of like to use yellow and orange more like highlighters when we have to get stuff on our page. I'm going to grab my orange for the axis of symmetry. the vertical line that divides a parabola into two symmetric parts. I'm going to go right down the y-axis here because the axis of symmetry in this case happens to be the y-axis. The vertical line that divides the parabola into two symmetric parts is our axis of symmetry. I'm going up to axis of symmetry definition. I'm highlighting that up there on top in orange as well. Don't forget that x equals is always a vertical line equation. X equals is a vertical line equation. Oh, I know, yeah? Now, once you have that, you turn your page in your notes, and that will tell me you're ready to go on. Mr. Abdullah might be using this, and if he is, which one? Orange. I used orange on axis of symmetry. For other geometry kids, Mr. Abdullah can pause it, what they need on that previous page. Now, if you guys could notice here with me on page 421, we've got the color version of this next page. On page 421 in our book, we've got the color version of this next page in our book, or next page in our notes. Page 421. Now, I don't know about you guys, but I think some of this stuff does look pretty complicated, doesn't it? It does look pretty complicated. Let's go first of all, and I'm going to use blue like they do in the book, to just identify that this middle parabola is that parent. And I know that because that's when a equals 1. So my middle blue is the parent, f of x equals x squared. That's what's in blue. They're talking about it right here too. Now, from our experience on the exploration, what kind of numbers are we talking about here when it says when a is between 0 and 1? In our fractions and decimals. So if a is between 0 and 1, fractions, decimals, I'm using my, oh, hold on a second. Yep, I'm using red right now. When a is between 0 and 1, those are our fractions or decimals. We describe this as getting wider or fatter. We described it as getting wider or fatter. But there's this idea that they use. They want us to change our thinking about this wider or fatter and call it a vertical shrink. Okay, so wider or fatter means vertical shrink. We got to make some sense out of that because, man, could this just be more odd? We're talking about it getting wider, and then they're using the word shrink. So I need to clear up for you what they mean when they say vertical shrink. So to go from blue to red, here's blue, my parent, here's red with a fraction. Why the heck do they call that a vertical shrink? It's getting fatter. Now, I want you guys to think about the x-axis. And this is where we make sense of this vertical shrink. I want you to think about this axis right here. That's the x-axis. When I go from blue to red, it's kind of moving out this way. Can you see I'm putting arrows here? They call it a vertical shrink. What that means is that the parabola is pulled towards the x-axis. Parabola is pulled towards the x-axis. The parabola is pulled towards the x-axis. So now we've got to consider this wider or fatter thing as being a vertical shrink. This wider or fatter is a vertical shrink. What was the other color? Now we got green. So in between, a fraction is going to give us a vertical shrink, wider or fatter. We'll keep repeating that so you guys can get a hang of it. Now right here, the smaller parabola in here is in green. And what I see over here as we start talking about that one is, this is when our value of a is bigger than 1. And you know what? I'm going to put a blue box around my parent again. The parent is still blue. So this is when your a is larger than 1. And we've been saying that that's skinnier or narrower. And we're going to call that a vertical stretch now. That's when it's skinnier or narrower, and we're going to call that a vertical stretch. Man, there's a lot already, isn't there? A lot of new vocabulary. Our goal is to be able to describe these changes based on a for the function a times x squared, and there's a lot of vocabulary that we've got to learn to do it. We're going to leave off right here for today. We'll pick up on the rest tomorrow. You can anticipate tomorrow in class doing some work on your own.